So welcome to my channel. I want to solve a nice problem which reads x to the power of x times x to the power of 3 divided by x times root of x equals to open bracket x to the power of 4x close bracket all to the power of x divided by x to the power of x times root of x. Then the questioner says what then is the possible value for x. So we are looking for the value of x in this challenge. Before we move on to solve this, let us look at this equation very clearly. We can see x is all over the equation because we are having x as a power number, we are having x as a base number, we are having x as a numerator, we are having x as a denominator. So how can we look for the value of x? So I advise you, if you are new to this channel, please kindly do well by clicking on the subscription button and hitting on the notification bell so that you get notified anytime I release videos on my channel. So let's see how we can resolve this nice challenge. So simply say solution. So say solution. Then write down the question, which is x all to the power of x times x to the power of 3 over x times root of x equals to, we are writing this x to the power of 4x close bracket all to the power of x over x to the power of x times the root of x. Okay, the next thing we can simply do is this. We can do two things here. We can either square both sides to remove these radicals. We can either square both sides to remove these radicals, or we can solve further without squaring both sides in order for us to remove the radicals. But I would like to choose solving further in order for me to remove the radicals, because if I should square both sides, it's going to give me more complex. It's going to be more complex solving it. So in order for me to avoid delay and stress, I would rather choose a shorter way of solving this without squaring both sides. So what am I simply going to do? The first thing I'm going to do, I'm going to assume that first we are not dealing with radicals. Then I'm going to deal with the numerator and the denominator first. Then afterwards, then I'm going to move on to the radicals problem. So doing that, I can say, okay, let's deal with this. Since we are having x to the power of x times x to the power of 3, from the principle of indices, so if we are having the same base number, take for example, we are having a to the power of m times b to the power of m, a to the power of n is also equals to, according to the principle of indices, since the base are the same, we'll pick them as 1 and the multiplication signs turn to an addition. So we are going to have a to the power of m plus n. So if we obey this rule at this junction, we are going to have our x, picking x as 1 to the power of x plus what? 3 over x times root of x equal to, we are having x to the power of 4x all to the power of x. Okay, remember from your simple indices again, if we are having a to the power of m close bracket all to the power of n is also equals to a to the power of n, right? So if we should obey this principle here, putting it, we are going to have our x to the power of 4x. X times x is going to give us what? X squared. So we're having x squared over x to the power of x times root of x. Okay, this is what I'm saying. We assume first of all that we are not having radicals. We assume, not that we don't have, we have, but we assume first we don't have radicals. Let's solve for others before we move on to remove the radicals. Okay, having done this, we can simply bring this to this other side, then bring this to this other side by cross multiplying, or we can simply divide both sides with x. So if we should do that, we're having x to the power of x plus 3. Okay, if we should bring this one up, we are going to have x times minus 1, because this one is coming up, all over root of x is equals to, doing the same thing here, we can have our x to the power of 4x squared, right, times x to the power of minus x over root of x. Since we've done that, okay, we cannot see at this junction we are having radicals. These radicals are similar. We can either cancel off them or we simply what? Cross multiply them. But in mathematics, if we are having 1 all over 2 is equals to 1 all over 2 is also the same thing as what? As 1, right? 1 all over 2 equals to 1 all over 2. So this and this can cancel off. So we are also equals to 1. So if you obey that principle here, we can simply remove this. Very easy. So this and this can go off, because if you do this, you just want to cross multiply this, you just want to multiply this, it can easily cancel out also. Okay, now we have removed the radicals without squaring both sides. There's a lot of ways you can remove radicals without just squaring. Okay, having done this, we can say x to the power of x plus 3 times x minus 1 is equals to x to the power of 4x squared times x to the power of what? Minus x. We're having square here. So our new equation is now x to the power of x plus 3 times x to the power of minus 1 equals to x to the power of 4x squared times x to the power of minus x. Okay, since our new equation is now this, we are now having x to the power of x plus 3 times x to the power of minus 1 equals x to the power of 4x squared times x to the power of minus x. So we can see that these bases are not the same. We can simply apply the principle of indices of the same basis. We are having a to m times a to b is equals to a to m plus b. So if we should apply this principle here, we are going to have our x to x plus 3. So since the bases are the same, pick them minus 1 equals to x to 4x squared minus what? X. Okay, because at this junction we apply the principle of indices. So doing that, we can say x to the power of x 3 plus 3 minus 1 is going to give us plus 2 equals to x to the power of 4x squared minus x. Okay, we cannot see that these bases are the same. And since the bases are the same, if we are having a to power of b equals to b to power of c, a to power of c, this and this can cancel, so your b is equals to your c. So if we obey this principle here, this and this can strike out, so we are left with x plus 2 is equals to 4x squared minus x. Okay, we can write the whole of this to be 4x squared minus x is equals to x plus 2. In order for us to make this a quadratic equation, so bringing the whole of this to this other side, we are now having 4x squared minus x minus 2 all equals to 0. Okay, we are not having this as a form of a quadratic equation, but we are not having minus x minus x. Minus x minus x is going to give us minus 2x. So applying there, we're going to have 4x squared minus 2x minus 2 equals to 0. And from here, we can solve with a factorization method, because now we are not having a quadratic equation. So if we multiply this with this, it's going to give us what? Minus 8. So we are going to look for two numbers. If we multiply those two numbers, they are going to give us minus 8. Then if we sum those two numbers or subtract them, they are going to give us minus 2. So what are those two numbers? Those two numbers are minus 4 and 2. So we're simply going to have our 4x squared minus 4x plus 2x minus 2 equal 0. Okay, furthermore, we can simply put a bracket. So we are having an addition sign here, right? We can put a bracket here. Put a bracket here, and put a bracket here, or put a bracket here again. So we're now having 4x squared minus 4x close bracket plus 2x minus 2 close bracket all equals to 0. Right. Okay, we can see at this other side we are having 4x as the common number. Then at this other side we are having 2 as the common number. So if you factor them out, we can have 4x open bracket x minus 1 plus factor to us, we are going to have 2 open bracket x minus 1 all equals to 0. Okay, since this and this are equal, we can pick them as 1. So picking them as 1, we can have x, 4x plus 2 multiply with your x minus 1 all equals to. Okay, so we are having an open bracket 4x plus 2 close bracket times x minus 1 all equals to 0. By equating each of them to 0, we can simply have 4x plus 2 is equals to 0. So looking for the value of x, we can say 4x is equals to minus 2. So if we should divide both sides by 4 to get our value for x, we're going to have x is equals to minus 1 over 2. And recall, we are also having x minus 1 is also equals to 0. So we are having x minus 1 also equals to 0. So if you look for the value of x here, so our x is also equals to 1. So our possible value for x is x equals to 1 and x equals to minus 1 over 2. So if you find this video interesting and useful, please click on the subscription button and hit up the notification bell. God bless you and bye for now. Thank you.